Hi, my name is Inayo. I'm David.
Yeah.
Not David.
Hi, I'm Abrar.
My name is David.
Okay. So first we'll begin our video with David and Abrar measuring our resistors, and then we'll set up our frequencies and to set up our oscilloscope right afterwards. So first we'll begin our video by demonstrating how to set up our multi-sim work. This is what we got for our multi-sim. We will be using a 1.5K resistor and a 2.7K resistor. And this will be the oscilloscope results once we are done setting it up. So first, to begin the video, David and Abrar will be showing the resistor values first. So for our first resistor, we get 1.476. We'll be writing that down in our notes. 1.476 ohms. Good.
We're gonna put this one here. Then this one, the other resistor. We're gonna put this one.
We'll make sure we're not doing anything. We're not going to do parallel. We will be setting up our circuit in series. So once that's set up, it'll be easy.
So it's 2.66.
2.66 for the resistor 2. And the lab will make note that we will not be measuring resistor 1, but instead our V in, so our voltage in, for our voltage in, and we'll be measuring the voltage across R2.
So we're gonna, right now we're gonna set up the frequency, positive, and function generator and the probe. And we need channel 1 positive. There you go. Channel 1 positive. And we start with the ground. All the ground power. Alright, now we're gonna put the frequency. Put the frequency at 500.
So for our voltage, not voltage, yeah.
Frequency
So for our frequency,
is 500.
we'll have 500, as we see in our report right here. Let me get a better view. Okay.
And we're
And then
gonna,
for our VRMS, will be 2.
alright.
As you can see, we are in AC world. We'll make note to make sure that it is in fact AC world. Oh, good.
Alright.
Okay. So now that's all set up. There you go. So now it's all set up. We'll begin closing. And Abrar, do you want to set up the circuit? Yep.
Yeah. Alright.
There you go. And Abrar will take over. Do you want to record?
Yeah.
Here you go. I'll help set up there as well.
Okay, what? Let's prepare here first.
Yeah, I'll help prepare
Now, okay, we will measure the BRMS again on my room.
Take these out so it becomes less complicated. We won't be needing these two any longer. This is our channel 1, channel 2, channel 1, 2.
Okay,
we are in
I will say only about the supply and what is this?
I'll connect the channel 1 and
Channel 1 and 2. Okay, perfect. You recording?
Yeah.
So you're on the right side here. You can go.
Oh, I can. This will be grounded. The supply here. Ground.
For channel 2.
R2. Perfect. The ground.
Okay. That should be grounded.
Turn on the oscilloscope.
Am I missing anything?
Yeah, function generator.
Our function generator. It's good. Yeah, we just got to. Okay, make sure we press auto. Awesome.
I need to remove that.
Oh, sorry.
I need to remove this. Yes.
Yeah, that looks about right. And you can see it does represent our source right here. And we will continue now by finding our time, our FN, and our VNP to P to P. So David, Abrar will be starting with
F in or
FN?
frequency.
Yep.
Yeah, frequency. So we're gonna disable the channel 2 and then we're gonna put this one in the big. Alright. There we go. We're gonna start with the position. So this is one cycle. We're gonna start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, we got 10 division. 10 div times. We got this is 200 microseconds.
right for our time.
Yeah, so we're gonna convert it. Alright, so we're gonna use the calculator. 200 microsecond. Negative 6 times 10. So we got 0.002 second, which is equivalent to 0.002 2 milliseconds.
For a period of time, right?
Yeah. So
Okay.
we got this from
Not
old
period,
school.
for a period of cycles.
Yeah.
That's the old school method, and as you can see, it also shows up on the multi-sim representation. Go ahead
And
for
now
the new
we're
school.
gonna we're gonna start new school time period. So it's showing
2 milliseconds, correct?
Yeah, 2.004. Alright, so we got 200.004 milliseconds. Now we know the F frequency is equal to 1 by T. So we're gonna put 1 by 2, 0.002 second. We're gonna do this 1.
Oh, okay.
0.00 is 500 hertz. So we got the input frequency, which is 500 hertz.
Okay. And as you can see, we are not surprised by that answer.
Alright, so we got our input frequency. Now we're gonna start with the.
You have to show. Oh, it's right here. Never mind.
So we're gonna start with B in peak to peak.
Is there a way to show this on New School?
Which one? This one?
Yeah, the frequency. Is there any way to show that? No, not that. This.
No. I don't think so.
You don't think so? I don't think so either. I could try it and see. Alright.
Time.
I want to see
You can show
something.
the frequency using time here.
Oh, you're right. Go ahead.
Alright,
Since
so
this is your part anyway,
A new school, you can.
So the
you just
B-
press time.
Alright. Now we're gonna start with the B in input voltage. So first we will do.
You can just press this and censor it.
Alright. Alright, so we got the old school. We're gonna do old school for the V in. 1, 2, 3, 4, 5. 1, 2, 3. 5 minus 6 division times 1 volt.
Bless you.
So it's equal to 5.6 volt. We got our in peak to peak 5.6 volt. Now we're gonna use the new school method to calculate this one. Let's see. Yeah, we also got 5.64 from there too. So this is old school V in peak to peak. That's 5 peak to peak. Now old school one is 5.64 peak to peak.
Alright, and that'll be all for David's part. Not David, Abrar's part.
To see the supply, the voltage in the RMS, we will use, we can calculate this value. We're using the VPP value. We can use with the DMM and oscilloscope. But to start, we can use the formula 0.707 plus VPP divided by 2. So using the calculator, we can use the formula VPP.
707.
We can use 0.707 plus VPP. We have the value here.
5.6 in our old school and new school method.
Yeah,
I say use the
divided by 2 is
1.967 or 97, my fault.
1.97
V in RMS.
V and RMS. Is that the one here?
RMS.
Oh,
Is
yeah.
that the one right here?
Yeah.
As you can see, it represents the one we have right here.
To use the DMM to check this value, we calculated this value, but we can check using the DMM. To use the DMM, we can measure the supply of the circuit. We can use the director on red to red and black, but we can capture here first. Is the same?
Yes, this is.
It's the same point. So you can see the value here, 2.01.
So it's basically same.
It's basically the same value.
Though the results aren't the same.
Yeah.
And now to check, we have here 2.01 VRMS using, and now we can measure using the oscilloscope. To check here, we can press measure, select the correct channel, is channel 1, voltage, and we can select VRMS. So we can see 1.97. We can check too. We can use the cursor if we decided to see a manual mode too. We can decide to measure.
I found out that you can. Fine. Oh, but I also found out that for the cursors, you can just. Can you press the cursors again?
Yeah.
Let's see.
No, I think it's fine. We got the result.
I think it's fine.
Okay. So you don't need to do.
Yeah. So we can.
Okay. We can capture on
1.97.
1.97 RMS.
Oh, that's fine.
Alright. So what? Start.
Sorry. So first, I'll be demonstrating how to use the DMM measurement first for our resistor 2. Simply positive to negative, negative first, negative, and
So it's
positive.
gonna connect the channel to
Okay. Let's see
DMM.
what we get here. We get
Resistor
1.29. For our resistor 2, 1.30.
Oh yeah, you got one.
Resistor 2, that's also what we got from here.
1.30.
I begin disconnecting. Now I'll show how we get our. The next one would be not V, our
V2 RMS on
V2
the
RMS. Yeah. So first, I'll do it
on the
old school first. So first, to get our V2 RMS, we'll press measure. We'll press not measure.
yeah. I think you
This should
can.
be time. V2 RMS.
No, on the other one.
Is it on? Oh, it's on voltage?
The voltage.
Oh, you know why? I got you. That's my own fault. Channel 1. V voltage and then V2 RMS. Okay. It'll be 1.30.
Yeah, it's almost the same. So 1.30.
It was damn near the same, right? Okay, so after we got our V2 RMS, which was 1.30, it should be volts. Now we'll start with our V2 P2P. Make sure everything is lined up. All you simply do is count 1, 2, not lined up, yeah. 1, 2, 3, 2, 4, and 6. You simply write it down. 3.6 V times 3.6 V times our 1 voltage source. Be 1, 0 V. And this was also division. My bad. This is your division. Cancel that out. We get 3.6 V for our voltage. RMS for our voltage source. Is it? Oh no, VPP. My fault. I put the wrong thing. Now to show our new school style, you just simply go to measure. You go to voltage. And you go to VTEC. Right here. 3.7. Not exactly the same, but it is near it. Go. So that's correct. And now we'll do our period of time, which is simply the same as the other one. You would simply make sure everything is lined up, make sure everything is even. You go 1, 2, 3, 4. 4. 3, 4. V, not V. DIV. 4 V DIV times
500
yeah, 500 times microseconds. My fault. Microseconds over DIV. Cancel. Calculator. All you simply do is 4 times 100. Oh yeah. Make sure it's in this. E -6. You get 0.002. And if you want to convert that, 10 to the third. 0.002 times. Easy equals 2. And as you can see, it is the same as our channel 1, but throughout the experiment, my fault, 2 milliseconds. But so throughout our experiment, we found, not experiment, throughout our lab, we found that the period won't change throughout the experiment. It won't change. It will only change to frequency, but any other factor, including our V2CP and V2RMS, won't change it.
All right. You wanna show in there the period?
Yeah, I got you.
All right.
So now all you simply do is this method. You go to time, press period, and 2.00 mm.
Oh yeah.
Microseconds. Yep.
All right. Thank you.